Hey, welcome out there. It's Thanksgiving Day, and if you're tuned in and watching us today, thank you. I thank you. We thank you, all right, for watching and tuning into our station. Our TNLearn Mathline. I'm Ernie Roberts, your host for Mathline today. It's not a call-in day. I know most of you are probably out there on the road. You're eating somewhere. You're getting ready to go out and hit those crazy Black Friday, or actually you now go Thanksgiving Thursday sales. But hey, we're glad you've tuned in this afternoon to check us out for a little bit of a Mathline Thanksgiving, all right? We're glad you're here. And again, don't call us today, but sit back, relax. Let's have some fun with some math here and maybe just refresh you on what went on with your dinner today or what you're expecting this evening, all right? Let's see what the story of the line is today. It's all about Thanksgiving. It's over the river and through the woods to grandmother's house we go. The horse knows the way to carry the sleigh through the white and drifty snow. And we go on and on. That almost sounds more like Christmas for the snow part. But a horse and a sleigh, you know, most of you kids who are watching today, you're going, what is he talking about? You hope you know what a horse looks like, but many of you probably don't know what a sleigh looks like. That used to be the way they would travel back in those cold days to get to grandmother's house for Thanksgiving, for big family gatherings and stuff. We know things are different nowadays. A lot of people just drive down the road. Some people drive a long way. It is the busiest travel weekend on our highways and in our airways that we have all year long. It's the Thanksgiving weekend. And I know many of you probably are already set and saying, I'm glad I'm off the road today, all right? But let's take a look at what we're going to do here, all right? Let's take a look at what's going on here. A situation. Let's look at grandmother and George, his family. Oh my goodness. It says grandmother lives 300 miles away from George and his family. So this is going to be one of those, we got to go a good bit of distance to get to grandmother's house, okay? If they can average 60 miles per hour, and the traffic, let me tell you, some of you say, that's kind of slow on the interstate. Not in Thanksgiving weekend. That's an average rate, all right? 60 miles per hour on the road. That may be actually giving him a little more time than he, you know, anyway. I may be giving him a little bit of a grace on that. I think it might be slower than that. But anyway, how long will it take to grandmother's house for us to get there and the family to get there if we keep at that pace? Notice this average 60 miles per hour. Sometimes you're going to go faster. Sometimes you're going to go slower. Sometimes you may just feel like you're in a total bottleneck and you come to a complete stop with the traffic, all right? So when we look at this problem, what we're thinking is very simply, how do we get those numbers to work, all right? And it's an easy little formula, so let me take you to it. And we use an algebra, we use an arithmetic, and we apply so many different things to it. And here we go. It's the rate times time equals distance. So how fast is he going times the amount of time it takes will get you to the distance, all right? So in this case, what it looks like, we're saying, we're looking for how long. So we're worried about time. We don't know what that little piece is, all right? But it's got to be something times the rate. Our rate is 60. That's going to get us to 300, all right? So, Grandmom, we're going to get there. We're going to get there. But we're going to see how long. We're going to see how long it's going to take us that we think we'll be on this road and on this crazy road trip, all right? So the rate is at 60. And that's miles per hour, okay? So we're thinking miles per hour is usually what we talk about. And we've got to multiply it times this about t, and that's going to give us this value of d, which is 300. Now, some of you are out there already laughing and says, my goodness, it doesn't matter what Ernie Roberts does, he can make an algebra equation out of it, right? So we got 60t equals 300. But the deal is, you can do this just by arithmetic and in your head. Divide the distance by the rate. That's the process, because if we take the rate times the time, the reverse process is going to be division. So here we go. We're just going to divide this thing out by 60, and we're going to figure out that it takes about 5 hours. Now, when you think about it, if you're going 60 miles per hour, that means 1 hour you're going to travel 60 miles. It means in 2 hours you'll do 120. 3 hours, it's 180. 4 hours, 240. Hey, it's just times tables, isn't it? It's pretty easy to figure out if you're going a nice round rate. If you're going like 67.5 miles per hour, get a calculator, all right? We'll figure it out that way. But with these nice numbers, you can do this real mental math type thing. And usually we tend to estimate when we're traveling and doing things like that. And when the kids, or when you ask, so I know I have a lot of adults here who are watching the show, and I also have a lot of kids, but when you say, are we there yet? Are we going to get there yet? You can figure out about how long it's going to take based on your rate and your distance. So do a division and have fun. Have fun. That's what we want to do today on Mathline, all right? Take a few easy things. Now we have some other folks here. Julie and her family, they're going to grandmother's house. This is a different location though. This time it's 280 miles away. And oh my goodness, they want to get there in 4 hours. Good luck on that, all right, on Thanksgiving weekend. Good luck on that speed. It says, what average rate of speed do they need to travel? All right, so we're going to take that rate times distance again. So we got it R times T, and we get our D going, all right? There's our distance. Now, when we're looking at this problem, you're asking, well, what do we know? We know how long we need to go. We have 4 hours. And we know how far we've got to travel. That was on the map. And with this time, we're going at 280 miles. What we need to know is, how fast is this going to happen? How fast is this going to go? And so this, again, is just good old arithmetic. It's nice round numbers here. And the good news is, since we're saying what times 4 will give us 280, we are going to divide by 4. Let me put that R back there, because we're going to have R times 4, and we're going to divide by 4. And again, we're going to do it both sides. There's that algebra equation again. Only this time I put the R and the 4 kind of differently. You would probably think, what could he have written for R? Sure, we call it commutative, all right? Even on Thanksgiving Day, you're going to hear the word commutative property, all right? Only on Mathline, only on Mathline. So let's see here. We are now at a rate, and you know what? This is miles. This is hour. So guess what? We have 70 miles per hour. And that's what we see, that MPH. That is our rate. That's our rate. How fast you got to go? Going to break speed limited spots maybe. Be careful. Be careful on that. But there's your deal. All right, so if you know the time you need and you know the distance, you can get the speed. If you know the speed and the distance, you can get your time down where you're going to go. And even more so, you can figure out how far you're going to be able to travel. If you know how fast you're going and how much time you're allotting yourself, you can figure out how close to Grandma's house or how far you can offset it, okay? So great little formula right there, great little formula. Now, when we hit the highways, we always worry about how much money is this going to cost us to make a long trip, okay? How much gas do we need? And first of all, you got to know how many miles per gallon is your tank getting, all right? So if you're wanting to go, let's say, 300 miles and you're getting 15 miles to the gallon, you're going to have to take a lot of gas, all right? You're going to be getting about 20 miles to the gallon, as we say there. So you're going to need, for those, in that 15 miles, what did I just say? 15 miles to the gallon, you're going to need about 20 gallons of gas right there, all right? So that makes a little bit of another type math. Sometimes it's not such a pretty one. But let's take a look at a situation here. Costing right now, gas is running around $1.80 to $1.90 a gallon in most places, 95 maybe. And the travel to grandmother's house uses 8 gallons of gasoline. Some of y'all get those little discount points, you know, and you lose some cents off your gallons at different places. Boy, everybody has a special on those nowadays, it seems like. But anyway, we're going to go for $1.85 per gallon. And it says the travel to grandmother's house uses 8 gallons of gasoline. What is the total cost of fuel for this trip? All right. So again, we come down to a real simple thought. Do we add, subtract, multiply, or divide? It's one of those operations, all right? And in this case, if 1 gallon costs, and that's what it means per gallon, that means 1 gallon costs $1.85. We want to think about how much does 8 gallons cost if it's going to take that much to get to this trip, all right? So we're going to take our $1.85, you know, and well, again, that's one gallon. If you bought 2 gallons, you would double the cost here, which would be about $3.70. And then we just keep working it up, okay? We can keep adding and adding, because that's what multiplication is, just repeated addition. But instead of doing all of that, let's just multiply. And we're going to take our $1.85 and we're going to multiply it times 8. That's why we learn times tables and those kind of things. It's very good. Now, some of you are probably going, Ernie, could we have estimated? Sure, take it to $2 and estimate it with 8, you would have $16. And that's a pretty close estimate. You're going to lose a little bit because you didn't quite get there, so it would be a little bit under $16. But let's check it out. Let's see what we end up getting. All right, do a little multiplication here on Thanksgiving Day. Yes, loving it, loving it. How about it? And by the way, once you get over the river, I hope you get, let's try that river and through the woods again. You'll be spending a little bit of money to get to Grandma's house if you got to use 8 gallons of gas. Let's see how much we're going to take. 5 times 8, of course, gives us 40. I'll put our 0 right there. Let's pop a 4 right up there. Okay, there we go. Very nice, very nice. And what I am seeing here, we've got 8 times 8, which is going to give us, wow, 64 maybe? 64. So let's see how that's working. 64, and we've got 4 to add to it, so it looks like we're going to have an 8. And then we've got our last deal here. Ooh, goodness, let's see. Put a 6 up there. 1 times 8 is 8. Add the 6. We have 14 there. $14.80 is going to be cost for our trip. So I said it'd be a little bit under 16. Actually, it's a little under 15, all right? Because when we say 15 off that estimate of $2, you know, I thought it would be around 16. We've got to remember, 15 times 8 gives us $1.20. That's another way of looking at it. A little estimate moment. 2 times 8, that gives us 16. 15 cents times 8, it's $1.20. And you know what? When we subtract that, we'll subtract that. That would also give us $14.80. There are different ways you can make your mind work on this math, okay? Estimates are great. Then figure out both estimates and subtract the results. There you go. Either way you do it, guess what? We got $14.80 coming your way to travel to Grandma's house, all right? So there we go. A little bit of this, that, and the other today. Now, we've got a little story of Antonio. Antonio may not be going to Grandmother's house, but he's been on the road some here, so let's see what's going on with his situation. It says it takes 4.5 hours to drive 225 miles. He's figured that out. Whew. He wants to go 6 hours. So he wants to know how far can he get at this rate in 6 hours. All right, this, folks, has a different twist to it. It sounds rather proportional, all right? So let's go with how much time, and we will put also 225. Now, I've got some others out there said, Ernie, could we put 225 over 4.5? We certainly could, and that would actually give us the miles per hour that we're going, all right, the rate of speed. So either way is fine. I chose to go hours to distance. Now, if you start with hours to distance, we got to stay with hours to distance, all right? So we're going to go for 6 hours, and we're going to try to figure out how much distance is that going to be. I'm going to the calculator on this one, folks. I am going to go to the calculator on this one. And then we'll come back and show you that you get the same thing when you start with 225 over 4.5. Let's go with it. Cross multiplying. I've got 4.5 times my missing distance there. We call it x, d, whatever variable you want to put in there. And let's see. We want to catch on to what is 225 times 6. I'm getting 1,350. Whew. Looks like a big number, but we're going to divide to figure out what it is. That's not how far he's going. Remember, we got to divide by that 4.5. And when we do that, divided by 4.5, we will get 300. And keep in mind, that is miles. That's how much he's traveling. That's how much he's traveling. Now, someone says, let's try it the other way. Why not? Let's put 225 over 4.5. And that's going to equal to my x this time over 6. Now, notice when we cross multiply. Over here, we cross multiply. The 4.5 went with x. 225 went with 6. I kind of jumped steps there. But it's the same story here. These are going to multiply, so we're going to get 4.5x. And the same thing going here. And, you know, we're going to still get 1,350. So it doesn't matter. Actually, this is a little bit nicer because this is miles per hour. And this tells me when I figure out this one over here, let's see how far we're going to travel. It's going to be 300. You know, it takes 300 miles to get in 6 hours. That basically means he is going an average rate of 50 miles per hour there. So it's another way to break it down. Rate of change, rate of change. A little bit of algebra proportions here on Thanksgiving. I love it, I love it. Hope y'all are giving thanks for having all these good things. Now, let's see check in on another family. This family is not going anywhere. They're not going to grandmother's house. But it says, John's family of 4 wants to have 10 others join them for Thanksgiving. What will be the cost per person of this meal? Now, I'm just going to kind of set it up for you. Then we're going to talk about what would be part of that meal, because this is making me hungry, really hungry out here. First of all, there are 14 people that are coming to the house, including the family, all right? So we've got 14 people. That's a lot of food, a lot of stuff. You want variety. You're going to have a lot of leftovers. Make sure you got plenty of baggies and big old tubs to give people all the turkey and ham and other good stuff that's left over. But to figure out the cost per person, you're going to have to total everything up, and then you would divide it out by 14. Now, a lot of times families do this because they weigh the facts. Should I take everybody out to dinner and pay X amount for a buffet? Or do we want to have our own home buffet and everybody bring food in? Or do I just want to treat everybody? All right, so this becomes a very, very important fact, because you don't want to overshoot your mark here, how much you can afford per person type thing. And plus, you're probably not going to charge your family and friends, we're going to charge you $10 to show up today at our house for Thanksgiving dinner. No, you usually try to do, it's almost like a little gift you let when you invite people in like that. People may bring their own food, or you may do it all yourself. So the question here is the total cost, once we figure out that total bill, and what's going to happen is you're going to divide it by 14, because that's how many people you're feeding. Now, if you're feeding 20 people at your family's house or somewhere, you would divide by 20. That would get you an average. It would get you an average cost per person for the meal, all right? So we're going to try to maybe run a little bit for this family, all right? Let's take a look at, what the meal might consist of a turkey, ham, stuffing, vegetables, fruit, bread, desserts, beverages of coffee, tea, and water. Well, they don't really cost much, because you're just basically heating them up, pouring water in them, and it's good stuff to drink. So anyway, so beverages and maybe cold drinks, soft drinks, and those other good things will cost you a little bit on there too, a little bit more, but these are just minimal costs. So we're really mostly concerned about turkey, the ham. Turkey is priced by the pound, folks. It's priced by the pound. You can get them now anywhere from 57 cents if you buy one, all the way up to $1.25 to $1.85, depending on what kind of turkey you want to get, all right? So, and it's cost per pound. You usually pay it per pound, and that would run you. So I'm going to go with let's see. How about, we'll go right in the middle here. We'll say about a $12 turkey. And we'll go with a ham. How about a ham that will be about maybe $18? We're going to show some numbers out here. Vegetables, stuffing, fruits, bread, desserts, all those things cost. All those things cost something. They're also very good. They're also very good. So we're going to say miscellaneously, let's say all these other items have costs to make, because usually at Thanksgiving time, we don't tend to just say, hey, have some corn. You usually doctor it up a little bit, make a corn casserole or a green bean casserole or sweet potato casserole. Oh, you get the idea, casserole city, all right? Bread, always fancy stuff, good stuff, rolls, biscuits, so I'm getting hungry. Stuffing, fancy it up, make it with all the good scratch ingredients. And desserts, great, all right? So here we go, $50, let's say we're going to spend on that. So here we go, final total on this meal. Whoo, drum roll, drum roll. We have $80 going here. Now we're going to take that $80 and we're going to divide it by 14. Whew. I don't know, maybe I'm underestimating this thing, but we're going to go for that. It looks like, folks, it's about $5.71 a person, all right? Not bad, not bad. You add the tea in there, you're probably up to around $6 a person on that. So typically, it's a good meal. It's a great meal. And we hope that you've had plenty of that today to eat, those of you who are watching this tonight. One more quick thought about turkeys. I said they're by pounds and ounces. So let's take a look at here. 1 pound is equal to 16 ounces. How many ounces will you find in a 14-pound turkey? All right. And that's bones and everything, all right? All sorts of good things. But 14 pounds is typically about what we deal with. And what we'd like to know is, how do we figure out how many ounces are there? Because that's kind of important, especially when we start asking that last question. Would it be enough to feed 18 people? And we have some guests come in besides the 14 that have already come to John's house for Thanksgiving dinner. So let's see. 1 pound equal to 16 ounces. Let's take that pound of 14, and we're going to multiply by 16, because that's how many ounces are in each pound. So we're going to change it all to ounces. So let's multiply it out, see what we've got. 4 times 6 gives us 24. Put the 4 down, push it up there. 1 times 6 is 6. Add 2, we got 84. I'm getting so hungry. 4 times 1 gives us 4. And then we got 1 times 1, which will give us a 14 here. Ready to add it up. A lot of ounces going on here. Ooh, 224 total. 224 total. 4 and 0 gives you 4. This gives you 12. Whew, bring it down. We've got 2. So the question is, will that be enough to feed 18 people? Now, I'm just thinking turkey part, all right? And some of that's bones, some of that's bones. So let's see what we get. 224, let's divide that into 18, or divide 18 into that. We're not going to go the other way. We're going to divide 224, and looking at that, 18 goes into 24, it goes 1 time. 1 times, we're going to run that times here. 1 times 18, wow. 18, that one's easy. Bring down, subtract, we get a 4. And we need to bring down the other 4. And folks, we got 18 going into 44 here. It's going to go 2 times with some left over. So here we go, 2 times 18, that's going to be 36. And I'm seeing 8 left over. And at this point, it's going to become kind of a messy situation. So what we're going to be looking at here, this is 4, it's going to be 8 over 18. And folks, remember that reduces down to 4/19. So basically, we're talking about 12 and 4/9 ounces per person. Is that enough? I think that's enough, okay? That's enough to have a little leftovers, and even the bones take up some of the weight and stuff. You're still going to get quite a good meal out of a 14-pound turkey for those 18 people, looks like. And plus, there'll be ham, there'll be stuffing, there'll be all sorts of other great things coming your way as we get ready for the Thanksgiving, okay? So, now, one more thing. Got to have dessert. Got to have dessert. So let's look at Cousin Ralph. He is cooking up a pecan pie, or pecan pie, depending on where you come from, for Thanksgiving. What is the volume if the circular pie pan has a 10-inch diameter and a depth of 1 inch? All right. Volume, folks, volume is a cylinder. All right. So it's going to be, it's a circle. So we use pi r squared. That's the circle formula. And we've got to accommodate for how tall or how deep it is. That's the height of this. All right. And think about it. Pi, we'll fudge on it. No pun intended for dessert, yeah. We're going to use 3.14 on that, all right? So let's see what happens here. In this case, if it's a 10-inch diameter, that means the radius is 5, all right? So here we go. Volume equals 3.14 times 5 squared times 1. That's not that deep, okay? But that's what I see. Most pecan pies are that way. And let's see. We'll multiply 3.14 times our 25, because that's what that good stuff means. See what we get. And you know what? I'm getting about 78.5. And by the way, those are cubic inches of good eating for dessert. There you go. So pecan pie for dessert. Everything else is good. Let's see what more we can find for you. Oh my goodness. One last quick question to you here. How about this one, folks? How many calories will be consumed by the average person at grandmother's house? I have no idea, okay? I am not equipped to figure that one out. That's a pretty big number, all right? Oh my, but enjoy those calories, And we do have one last moment, very serious moment here. It is Thanksgiving Day, and we want to ask, how many blessings do you have for this Thanksgiving holiday? And you know, maybe that is how we define infinity, that upside down 8, or lopsided 8 as we like to look at it. Let's see if I can do a better infinity here. There we go. Infinity, infinity, infinity. There are so many, and we thank you. I want to thank also our sponsors who you see every day at the beginning of our show. Thank them for being here. Thanks my crew who puts up with me and deal with me on a day-to-day basis, and we have a good time here. Jim, Richard, Sam on him coming in, Clay on other things, all the great folks who work with us, Chris who produces us here, and just all of us folks out there. And thank you for viewing with us. Thank you for calling in day after day. We're going to have one more good old show tomorrow on Black Friday, but we'll see you then. Thanks for being today.